4 is all about transformations, and there are 4 basic transformations that we are going to look at this week. The first one we're going to look at today is translations in section 4.1. So 4.1 translations, the learning target is I can perform translations in the coordinate plane. So I can perform translations in the coordinate plane. I did grade and put in the gradebook your quiz from Thursday over chapter 12. I had a couple people missing it. I'm going to connect with you guys tomorrow about making that up. But if you did take your test on Friday, it is in the gradebook. Okay, so translations are one of the 4 basic transformations that we're going to look at this week. A transformation of a geometric figure is a change in the size, shape, or position of the figure. So you practiced looking at a couple different transformations on Friday in those Desmos activities. So it's a change in the size, shape, or the position of your figure. And it just says a geometric figure. That just means any shape, like a triangle, a square, a rectangle, whatever we have on the coordinate plane, a change in the size, shape, or position. We've got 3 really basic transformations. The first one we're going to look at today, which is a translation. A translation is also known as a slide, so sliding the shape around. Tomorrow we're going to look at a reflection, which a reflection is also known as a flip, flipping the figure over a line. And then Wednesday we will look at a rotation, and a rotation is also known as a turn, so turning the way that the shape is facing. Okay, in any transformation, the original figure is called the pre-image. So whatever you're starting with is called the pre-image. The resulting figure, so whatever you get after you slide it, flip it, or turn it, is called the image. A transformation maps a figure onto its image. So in these 3 basic transformations, something happens to map a figure onto its image, and sometimes we describe it with arrow notation, which you'll see an example of down here, but it's just going to have a little arrow. Prime notation uses an apostrophe. It's sometimes used to identify the image points. Sometimes a new set of letters is used. And so for like example, if I have a shape A, B, C, D, and I have some transformation that changes it, my new shape, my image, is A prime, B prime, C prime, D prime. And I know that this is the new shape because of this prime notation. I know that the transformation took place because of this arrow notation. Okay, a rigid motion is a transformation in which the pre-image and the image are congruent. Remember from way back in chapter 1, congruent means that there are two shapes that are the same size and the exact same shape. So one might be over here and one might be down here, but they're the exact same shape. And so a rigid motion maps the pre-image and the image to be exactly the same. So it didn't change the size of the shape and it didn't change the way the shape was. All it did was move it around in some way, and that's called a rigid motion. Okay, so today we're really focusing on translations and how those transformations work. So translation moves every point of a figure in the same distance and in the same direction. So transformation moves every point of a figure the same distance in the same direction. So here it says the translation maps the points P and Q to P prime and Q prime. Remember that anytime you have the prime notation, you know that's your new shape. That's what happened after the transformation took place. So here we've got this point P and we've got this point Q. And some transformation moved P up here to P prime. So it moved along this line up here. And then some transformation to, or translation took Q up here to Q prime. So this is where Q ended up. That's where P ended up. The translation rule looks like this. So you start out with X, Y. So P and Q were just points on the coordinate plane. They had some XY location, like 2, 3, 1, 4, whatever it was. And then to move it to P prime, we added some value A to X and some value B to Y, and that's how we moved it on the coordinate plane to get that new image. So here for these examples, it says write a rule for the translation of quadrilateral PQRS to quadrilateral P prime, Q prime, R prime, S prime. So we started out with this original shape, and it turned into this shape, and I'm going to write a rule that looks like this, but I'm going to figure out what A and B are. So my rule is going to look like XY translates into, and then I'm going to have X plus some number or minus some number, and Y plus or minus some number. So the way that you can really tell is just pick a point, and it really doesn't matter which one you want to pick. I'm just going to look at P. Okay, so P was here, and now I'm up here at this point P prime. P turned into P prime, and I want to figure out how I went from here to up here. So remember that my X values are how it moves left and right. So if I'm looking at P, it went this way. Okay, I'm going to count specifically how many units it went. It went 1, 2, 3, 4. So P went to the right 4. If I go to the right, that's going to be a positive A value. So I'm going to have X plus 4 because I went to the 4 over this way. It also went up. And if I count, I went over 4 and then I went up 1, 2, 3. So it went up 3. So that's going to turn into Y plus 3. Okay, so right movement is plus. If I had gone to the left, I would have written minus. And then upward movement is plus as well, but if I went down, I would write minus. Okay, I'm going to give you literally only 30 seconds to try to come up with the rule for this one, and then I'll go over it. Okay, it was fast, but let's go over it. So again, you don't have to pick P. You can pick any point you want and just see where it maps to its image point. So instead of picking P this time, I'll pick S, but you can pick any that you want. So S maps into S prime, and I'm trying to figure out what happened to get from the point S here to the point S down here. So it looks like I went over. I only went 1, so it's kind of hard to squeeze it in there, but I went to the right 1. And going to the right is actually positive, so it's going to be +1. It's not -1 because I'm thinking about how did I get from here to here, not from this point to that point. It's the pre-image to the image. I went to the right 1. So I went to the right 1, and then I went down, and I went down 1, 2, 3. So I went down 3. And going down is subtraction, so it's on my y values, though I subtracted 3. Any questions on those two examples, just writing the rule for the image for the pre-image to the image?